So this video is designed to be a quick starter guide for having an Arc Plus Touch talk via SNMP to various pieces of equipment. We're going to do a demonstration today with a Nautel VS1 transmitter, get some basic parameters on, off, etc. set up. So if this is something you've thought about, you've wanted to do, but didn't quite know where to start, hopefully once we walk through it, you can take what you learn here and go off and run with it and do all sorts of SNMP monitoring and implementation. So there's several SNMP commands, but the two we're going to deal with today are the basic get command and the set command. So with an SNMP get command, basically the remote control is reaching out to the transmitter in our example and saying, hey, I'd like to get a piece of information, for example, a forward power reading. And the transmitter says, sure, here you go, it's 1004 watts. The other basic setting we're going to use is the SNMP set command. And with the set command, basically, the remote control is controlling the transmitter. It's setting a parameter. So it's reaching out and saying, I'd like to issue command 1 for on-off. And that's going to turn the transmitter on. And the transmitter says, I see you've issued me a command number 1. I'm going to turn the transmitter on and issue you a 1 back as a status confirmation. So let's get started. The first thing we're going to do is hop into the piece of equipment we want to control, in this case the Nautel VS transmitter, and make sure SNMP is set up. We're also going to change the default public and private community strings. By default, most pieces of equipment will have public as the read and private as the write. We're going to change this to IHMGF for Grand Forks, since this is where the transmitter is located, and IHMGF write for the write community. This will add a little bit of security to our setup. So now we need to add the piece of equipment to the Bruk, and we're going to do that through auto load. Go to the edit menu and add an SNMP device. We're just going to click add, give it a name of our Nautel VS1 transmitter. We're going to input the IP address, leave the port 161 alone, that's default SNMP port. But we are going to change the read string and the write string to what we set it in the Nautel for IHMGF and IHMGF write. When we get that part done, we're going to load a MIB file. You can get that from the manufacturer. Sometimes it's embedded in the equipment. If it's got a web page, sometimes it'll give you the option to download it. I have it stored on my laptop, so I'm going to load that up. A MIB file is basically kind of like a phone book. It's a listing of all the parameters that are available to be monitored via SNMP in the device. And when we start selecting parameters, this will make it a lot easier because we'll be able to jump in and say, here's the list of parameters, and here's the ones that I would like to monitor. Let's hop to the meter channels and start sucking some data out of our transmitter. We're going to just choose channel 80 here and label it as our forward power sample. And then we're going to go to the right-hand side and set this channel by SNMP. We're going to choose our transmitter, and then we're going to open up the OID browser. Essentially, this is browsing the MIB file I just referenced a couple of seconds ago, our phone book, so to speak. We're going to drill down through the menu to our VS and to our VS controller, which is where parameters are located. And here we've got a parameter for our forward RMS power. If we click get, it's going to give us a value of 0 because the transmitter's off, but that verifies that the Bruk is talking to the piece of equipment and getting a valid reading. So we click OK, and now we see that that channel is set by SNMP. The long string of numbers that you see is what's called an OID number. Those are all contained inside the MIB file, and for old school, you could say that's kind of like its phone number, so to speak. So it's the reference number. We're going to do the same thing now to pull the reflected power value out. We're going to set it by SNMP, choose our Nautel transmitter, click the Browse button. We're going to drill down and find what appears to be reflected power and click OK. And again, we're going to click OK and set it up. And now we are pulling that data out of the transmitter by SNMP. So by doing that in the meter channels, we've basically told the Bruk to issue get commands to the transmitter to get those forward and reflected power values. Now we can hop over to the command channel, and we're going to set them up again by SNMP, but this time we're essentially going to be setting up set command. Same concept, we're going to choose channel 80, go over to the right, and we're going to set this up as SNMP. And we're going to click on the little button next to the raise on. And again, we're going to open our MIB browser and drill down, and in the controller section we have controller RF on off. I'd like to focus for a minute on the description, because this is basically telling us the commands that we need to send as set commands to the transmitter to make it behave as we want to. So if we issue a 0 command, that turns the transmitter off. If we issue a 1 command, that turns the transmitter on. And if we were to issue a 2, that would issue an inhibit, or basically an RF mute command. So we're going to click OK, and then in the data type, because this is our raise on to turn the transmitter on, we're going to make it integer 1. And that'll issue that 1 command via set command over to the transmitter to turn the transmitter on. Now for our lower, ideally, we'd want to turn the transmitter off. So again, we're going to drill down, and we're going to choose our controller RF on-off. Again, 0 means off, so we're going to set our integer to 0. So when we hit the lower button, it'll issue a 0 command to the transmitter as a set command and turn the transmitter off. We'll go ahead and label these raise and lower labels so they show up in our buttons, and we'll go ahead and hit save. We're going to add a couple of more commands because I want to show you how SNMP can be a little bit goofy from time to time. This Nautel backs up 2 stations at the same site, so it's got 2 presets in it, and we can go ahead and assign those presets to command channels in the Bruk to make changing frequency easier. So we're going to go ahead and label a couple of channels for the 2 frequencies that we have, and again, like we did before, I'm going to go over to the right, and we're going to set this channel by SNMP. Click the raise on, and we're going to have raise set it as 92.9 frequency, and we're going to drill down into the Nautel as we did before, into the VS controller. One of the things I want you to notice here is what's called the offset value. So when we look at the preset index, we'll notice the presets are offset by 4096. So if we want preset 1, we have to choose 4097 as our integer that we send. If we want preset 2, 4098, and so on and so forth. It'll also return via get command an indication of what preset is currently in use. And it returned 4097 when we checked it just a minute ago, and that basically tells us that it is on preset. If we issued a get command and it returned 4098, then we're on preset 2. There's nothing standard about offsets between manufacturers, so they'll put the notes in the MIB file, and it's up to you to look at it to make sure you're offsetting things correctly in your get request, and also offsetting things correctly if you're issuing a set command to change something on the transmitter or other device. Okay, let's use what we've learned and hop over to the Status Channels tab and create a couple of statuses to tell us if the transmitter's on or off. And we're going to go back to essentially the same OID that we used to turn the transmitter on and off with command channels. So we're going to hop into our browser and drill down and go ahead and find that OID. And it's going to be a 0, 1, or a 2. And those are the same indications we use for a set command, and those same integers we use as a get command to drive the status. So if we have a value of 0, that tells us the transmitter's off. If we change that to a value of 1, the status will turn on when the transmitter is turned on, because it'll issue a get command, the transmitter will report back, I'm status 1, and that means transmitter is on. We can do the exact same thing with status indication of the preset. So we issued commands just a minute ago to change the preset from 1 to 2 using those offset values. So we can now get the status of which preset is in use in the transmitter by going back in and using those same offset values to drive status indications. So we're going to drill down, go down to the active preset, again offset by 4096. We see that 4097 is the current value. That means preset 1 is in use, 4096 plus 1. So we're going to use that value to turn on the status 81, and then we can go ahead and drill down and do the exact same thing, and we can use integer 4098, 4096 plus 2, to tell us that preset number 2 is in use, and the transmitter is currently sitting there on frequency 107.5 to back up the other station that is in use at the transmitter site. So the Bruk issues get commands. It looks at the integer coming back. If the integer matches what we type in for that status, it turns that status on or off. And now if we hop into autopilot, we can see a quick GUI representation of the work we just did that I put together. We can hit our frequency button, change the preset in the transmitter, get a status indication back. If we turn the transmitter on, here's a picture I took earlier of metering indications coming back by SNMP showing the aux transmitter on. Again, we get status indications. All of that we built with SNMP using the simple commands that we just stepped through. There's so much more to explore. Just in this transmitter alone, there's hundreds of parameters that can be measured and logged and put into the remote control. And a lot of other SNMP devices work just the same way. It's a very simple concept. So as you start to look around, look for things that are connected to Ethernet jacks, and you can pull out SNMP data like UPSs and automatic transfer switches. You can log and view that data. Modern day dehydrators can spit out all sorts of data in real time via SNMP, even STLs, barracks boxes, wireless links to transmitter sites. Lots of possibilities these days for monitoring devices by SNMP, so take a look around. You might be surprised at some of the devices in your facilities that you haven't thought about yet that have SNMP enabled on them, and you can suck that information right into the remote control. One final word, the Bruk Arc Plus Touch only does version 1 of SNMP. There's currently version 1, 2C, and 3. So if the device you want to monitor gives you a choice of which version of SNMP to use, you want to go ahead and set that for version 1. Otherwise, get in there and start playing with it. You'll get your feet wet and see how easy it is to monitor by SNMP.